Now let's first draw the Gantt chart using SJF algorithm, okay, for this table. Fine. As usual, we will always start from time unit 0. Okay, we will always start from time unit 0. And at time unit 0, see, actually we are using here SJF, okay, not SRTF, SJF. At time unit 0, the only process which has arrived is P1. Okay, no other process has arrived. So our scheduling algorithm will schedule P1. Fine. Now since we are using, since SJF is a non-preemptive scheduling algorithm, P1 will continue until its completion time, right? And it needs 20 time units from the CPU, so it will keep going until 20. See, one more point again for this problem, we assume that IO time of all processes as 0, okay? Okay, this is our assumption. Fine. Now at time unit 20, the only process which has arrived is P2, okay? No other process has arrived, right? So P2 will be scheduled and P2 will be going for 25 time units, right? 20 plus 25 is 45. Fine. Now at time unit 45, both P3 and P4 has arrived, out of which the shortest job is P3, right? Because P3 needs only 10 time units from CPU, whereas P4 needs 15 time units. So we will be scheduling process P3 and it will be continuing until 55, right? Fine. Then we have only P4 and so we will schedule it, right? So P4 will be scheduled and P4's execution time is 15 time units, so it will go on till 70. Okay, fine. So this is what the Gantt chart we update through SJF scheduling algorithm. Okay, now the same thing let's draw for SRTF. Okay, shortest remaining time first scheduling algorithm. We will always start off with time unit 0 time units, and the only process which has arrived is P1. Now let's execute P1 until 15 and first and then check. Okay, why I'm doing it until 15? Because there is a process which is arriving at time unit 15. Okay, now in case if I go for, just a second, let me erase it out so that it will not confuse. Okay, fine. Now out of this, after executing for 15 time units of P1, this will become 5, right? Now at time unit 15, we have both P1 and P2 in the RAM, out of which the high priority process nothing but P1, right? Because it needs only 5 time units, whereas P2 needs 25 time units. So we will again continue with P1 and P1's execution time will proceed until 20. Fine. Now at time unit 20, we have only P2 in the RAM, right? So P2 will be scheduled, fine. And P2 will be continuing, see this has become 0, right? This has become 0 and P2 will be continuing at least until time unit 30. Because at time unit 30, P3 is coming. Fine, so it has executed for 10 time units. So I am subtracting 10 from this. So it has become 15, fine. Now out of P2 and P3, the process with the highest priority is process P3, right? So we will be continuing P3 at least until 45, but it doesn't need until 45, right? It needs only 10 time units from the CPU. So in that case, it will go till 40 and this is done, right? This is completely done. Fine. Now P4 has not arrived to the RAM. We have only P2. So we might have to schedule P2 at least till 45, right? Because at 45, P4 is arriving to the RAM. Fine. So P2 has executed for 5 time units. So I'm making it as 10. Fine. Now we have P2 and P4, out of which the process the highest priority is P2 because P2's execution time is less than P4's execution time, remaining execution time. So we will again continue with process P2 and then we will complete it, right? P2's execution. It will execute till 55 time units. So P2 is done. Now we have only process P4. So we will continue P4 for 15 time units. Okay, fine. Okay, now you can calculate the completion time on all this, right? Completion time, waiting time, and all this. That will not be actually difficult for you, right? I know that. Now let's calculate something called as response time. Okay, we have not seen it till now. Let's see what is meant by response time first. Response time is nothing but waiting time. Response time, for every process we have a response time. Okay, for every process we have a response time. Now response time is nothing but waiting time of that process until it gets the CPU for the first time. Okay, until it gets the CPU for the first time, the time spent by the process waiting. Okay, that is what we mean by response time. Now see this, let's calculate the response time for every process, say P1, P2, P3 and P4, considering it as SJF. Okay, here let us assume we are seeing this, and for this we are going to calculate the response time of P1, P2, P3 and P4. Let's see this. P1's waiting time is, P1 has arrived to the RAM at time unit 0 and it got the CPU at time unit 0 itself, which means before getting the CPU for the first time, P1 has not waited for any time. Once it came to the RAM, it straight away got the CPU. So its initial waiting time, which means waiting time before getting the CPU for the first time, is just 0 time units. Okay, so response time is 0. Now what about P2? P2 arrived to the RAM at time unit 15 and it got the CPU time unit 20, so it has waited for 5 time units initially. Okay, and P3, what is the P3 has arrived to the RAM at 30 at time unit 30 and it got the CPU at 45, so it has waited for 15 time units. Okay, similarly process P4 came to the RAM at time unit 45 and it got the RAM at time unit 55, so its initial waiting time is 10. Now let's take SRTF. Okay, see, you will find the difference of response time in case of preemptive, non-preemptive. Now see this. Now let's see the response times of, let's first see the response time of process P1. See, we are now considering this, okay, SRTF, not SGF. Fine. Now let's see what is the waiting time of process P1. Okay, P1 arrived to the RAM at time unit 0 and it got the time unit and it got the processor at time unit 0 itself, which means before getting the CPU for the first time, it has not waited, right? It has not waited for any time. So its initial waiting time, which is nothing but response time, is just 0. Okay, see, there is a difference between waiting time and response time. Okay, waiting time means after coming to the RAM, the total time spent by a process in waiting for the CPU. Okay, that is what we mean by waiting time. Whereas in case of response time, the time spent by a process before getting the CPU for the first time. Okay, that's what we mean by response time. Let's see this. Okay, now what is the response time of P2? P2 has arrived to the RAM at 15 time units and it got the CPU at 20th time unit, so it has waited for 5 time units initially before getting the CPU. See, waiting time of P2 is different. Why? Because P2 has arrived at 15 time units and it got the CPU at 20th time unit, so it has waited for 5 time units initially. After that, it has waited for 10 more time units, right? This should also be counted in case of waiting time. But in case of response time, we don't count this because our response time is nothing but initial time waited by a process before getting the CPU. Okay, this should not be counted. But in case of waiting time, we need to count this as well. That is the difference between response time and waiting time. Okay, now let's see the response time of P3. P3 has arrived to the RAM at time unit 30 and it hasn't waited for any time. Once it came to the RAM, it straight away got the CPU. So its initial waiting time, which is nothing but response time, is 0. Now what about process P4? P4 came to the RAM at time unit 45 and it got the CPU at 55, so it has waited for 10 time units, right? which means P4 came at 45 and it got the CPU at 55. So it has waited for 10 time units. Okay, so this is the response time. Now you can just add all of them and divide it by 4, you'll get the average response time. Okay, so one important point I need to discuss here is, in any non-preemptive scheduling algorithm, response time equal to waiting time. But this need not be true for SRT, for non-preemptive scheduling algorithms. Sorry, this need not be true for preemptive scheduling algorithms, right? Why this is true? See, in any non-preemptive scheduling algorithm, response time equal to waiting time. Why? See, in case of non-preemptive scheduling algorithm, whenever a process gets the CPU, it will complete its execution, right, in one go, which means after getting the processor, a process will never be preempted. See, in any non-preemptive scheduling algorithm, whenever a process gets the CPU, it will never get preempted, right, until completion, which means whenever the process gets the CPU, it will complete its execution without being preempted, right? So, the response time, which means the initial waiting time before getting the CPU for the first time, is the total waiting time by a process, right? A process will never wait for one more time, right? But in case of non-preemptive scheduling, that is not true. See, but in case of preemptive scheduling, that is not true. In case of preemptive scheduling, a process might wait for some time before getting the CPU for the first time, as well as it might get as well as this process might get preempted for some time, and then it might have to wait for some more time before getting the CPU for the second time, right? That can happen. That is one of the possibilities. So that's what I mean by this. In any non-preemptive scheduling algorithm, response time equal to waiting time, which means initial waiting time of a process before getting the CPU for the first time is equal to the total waiting time of the process after it has come to the RAM until completion. Okay, that is what we mean in case of non-preemptive scheduling algorithm. But in case of preemptive scheduling algorithm, this need not be true. Okay, this is a very important point. That's the reason I have discussed both SJF and SRTF. See, SJF is a non-preemptive scheduling algorithm. It is one of the non-preemptive scheduling algorithms. We have a lot of non-preemptive scheduling algorithms. Okay, we will see one by one. We have some other non-preemptive scheduling algorithms as well. For example, first come, first served. But in case of SRTF is one of the preemptive scheduling algorithms. We have some more preemptive scheduling algorithms. For example, round robin. There are a lot of preemptive scheduling algorithms. We will see that one by one. Okay, fine. Now please make a note of these 2 points. Okay, these points are very important. Fine.